AI has gone too far, and it's time we talk about it. From algorithms affecting job prospects to AI-generated deepfakes spreading lies, AI's rapid advancement impacts our lives in ways we never imagined. Have we unleashed a technology beyond our control? Before we go into that, the question lies, how far back does the idea of artificial intelligence go? The early beginnings and theoretical foundations of artificial intelligence, or AI, can be traced back to ancient philosophies and myths, where ideas of artificial beings and mechanical automation first emerged. Greek mythology, for instance, introduced Talos, a giant automaton built to protect Crete. These early imaginings set the stage for later scientific exploration. Mathematical foundations laid by figures such as Euclid and Al-Khwarizmi were crucial, as their work on algorithms and logical reasoning became fundamental to AI development. The formal conceptualization of computing machinery began with Al Turing in 1936, whose theoretical Turing machine proposed that a machine could perform any conceivable mathematical computation if it were representable as an algorithm. Turing's work provided a pivotal framework for understanding computational processes, thus laying the groundwork for modern AI. His famous Turing test, introduced in 1950, further explored the potential for machines to exhibit intelligent behavior indistinguishable from that of humans, sparking ongoing discussions and research in the field. The Turing test assesses a machine's ability to exhibit human-like intelligence. In this test, a human evaluator converses with both a machine and a human through text. If the evaluator cannot distinguish the machine from the human, the machine passes the test. This concept shifted the focus from defining thinking to practical benchmarks for machine intelligence, sparking ongoing debate and guiding AI research into replicating human cognition and interaction. Despite criticisms and evolving interpretations, the Turing test remains a foundational idea in AI. So what sparked the transition from theoretical concepts to tangible AI advancements? The answer lies in the mid-20th century, a period marked by significant breakthroughs and milestones that propelled AI from abstract ideas to concrete research. The Dartmouth Conference of 1956 is often hailed as the birthplace of AI as a formal field of study. Here, a group of visionary scientists, including John McCarthy and Melvin Minsky, coined the term artificial intelligence and laid the groundwork for future research. This era saw the development of symbolic AI, which focused on using symbols and rules to simulate human reasoning. One of the early milestones was ELIZA, created in 1966 by Joseph Weizenbaum. ELIZA was a natural language processing program that simulated a psychotherapist, demonstrating the potential for machines to engage in human-like conversations. Around the same time, Shaky the Robot emerged in 1969 as the first general-purpose mobile robot capable of reasoning about its actions, showcasing the potential for AI in robotics. While such progressions were made in this period, it evidently came to a slowdown. Why? Hasn't technology ever advanced rapidly from here? Well, you'll see. During the 1960s and early 1970s, AI research made bold predictions about the imminent capabilities of intelligent machines. However, the reality lagged far behind these predictions. Early AI systems, particularly symbolic AI and expert systems, struggled with real-world complexity. These systems relied heavily on predefined rules and lacked the ability to learn or adapt, leading to disappointing performance outside controlled environments. Consequently, government and private sector funding dwindled, and skepticism about AI's potential grew. The AI resurgence began in the mid-1980s, driven by several key developments. Researchers started exploring machine learning, a paradigm shift from rule-based systems to models that could learn from data. The introduction of backpropagation in neural networks, which improved the training of multi-layered networks, was a significant breakthrough. The 1990s saw further advances with the rise of more powerful computers and the availability of large data sets. These resources enabled more sophisticated machine learning techniques, including support vector machines and ensemble methods. AI began to demonstrate practical utility in various applications, such as handwriting recognition and data mining, gradually restoring confidence in the field. The resurgence gained momentum with IBM's Deep Blue, defeating world chess champion Garry Kasparov in 1997. This milestone showcased the potential of AI in strategic thinking and complex problem-solving, reigniting interest in investing in AI research. The AI winter had ended, paving the way for the era of big data and deep learning that followed. Modern AI has experienced a renaissance, largely driven by advancements in deep learning, a subset of machine learning that leverages neural networks with many layers, hence deep, to model complex patterns in data. This resurgence began in the 2000s, catalyzed by several key factors: the exponential growth of computational power, the advent of big data, and breakthroughs in neural network architectures. Deep learning's impact became particularly evident with the development of convolutional neural networks, or CNNs, for image recognition. In 2012, a CNN called AlexNet significantly outperformed other methods in the ImageNet Large-Scale Visual Recognition Challenge, reducing the error rate by a remarkable margin. This achievement demonstrated the superior capability of deep learning models in handling vast and complex datasets. The successes in image recognition soon translated to other domains. Recurrent neural networks, or RNNs, and their variants such as long short-term memory, or LSTM networks, advanced the field of natural language processing, or NLP. These models excelled in tasks like speech recognition, language translation, and sentiment analysis, driving innovations in applications ranging from virtual assistants to automated customer service. One of the most significant milestones in modern AI is the development of large language models, particularly OpenAI's Generative Pre-trained Transformer, or GPT series. GPT-3, released in 2020, showcased unprecedented abilities in generating coherent and contextual relevant text, performing tasks such as writing essays, summarizing information, and even coding. These models leverage transformer architectures, which excel at capturing long-range dependencies in data, making them highly effective for language-related tasks. Deep learning's influence extends beyond NLP and computer vision. In healthcare, AI models assist in diagnosing diseases from medical images, predicting patient outcomes, and personalizing treatment plans. Autonomous vehicles rely on deep learning for object detection, path planning, and decision-making, pushing the boundaries of what AI can achieve in real-world environments. Despite all these achievements, why did we title this video "AI Has Gone Too Far"? That's because there are huge ethical and societal questions with AI. Users and creators of such models hover over many ethical gray areas. One of the most pervasive concerns surrounding AI is its impact on privacy. AI systems often rely on vast amounts of data to function effectively, which can lead to invasive data collection practices. A stark example of this is the Facebook Cambridge Analytica scandal. In this case, the personal data of millions of Facebook users was harvested without their explicit consent and used for targeted political advertising. This incident highlighted the vulnerability of personal information in the age of AI and raised questions about the ethical use of data. Similarly, AI-driven surveillance technologies such as facial recognition systems deployed in public spaces can track individuals' movements and activities without their knowledge, leading to an erosion of personal privacy. AI's ability to make decisions on behalf of individuals introduces significant ethical dilemmas regarding autonomy and consent. Autonomous vehicles, like those developed by Tesla, can make critical decisions in real time, such as how to react in potential accident scenarios. These decisions might involve life or death outcomes, and passengers as well as pedestrians have little to no control over the AI's choices. The lack of consent is troubling because it places humans in the hands of algorithms, raising questions about who's accountable in the event of a failure. Moreover, AI systems in healthcare, such as diagnostic tools can influence medical decisions, potentially overriding the judgment of human doctors. Patients might not fully understand or agree with the AI's recommendations, yet they are often not given a clear choice in accepting or rejecting these automated decisions. The potential for AI to manipulate and deceive is another profound concern. The advent of deep fake technology exemplifies this risk. Deep fakes use AI to create highly realistic but entirely fake videos of individuals. For instance, a deep fake video of former US President Barack Obama was created by researchers to demonstrate how easily public perception can be manipulated. Such technology can be used maliciously to spread misinformation, disrupt political processes, and damage reputations. Additionally, AI algorithms used in social media platforms can promote polarizing content, as seen with YouTube's recommendation system, which has been criticized for driving users toward extremist content. This manipulation can deepen societal divisions and skew public discourse, undermining democratic processes. One of the most pressing societal concerns regarding AI is its potential to displace jobs. As AI technologies become more advanced, they are increasingly capable of performing tasks that were once the domain of human workers. For instance, Amazon's use of robots in warehouses has significantly increased efficiency, but has also led to the displacement of many warehouse workers. Similarly, AI-driven automation in industries such as manufacturing, customer service, and even legal services threatens to render many jobs obsolete. While AI can create new job opportunities, particularly in the tech-related fields, the transition can be difficult for workers whose skills become redundant. This shift could exacerbate economic inequality, with benefits accruing to those with the means to adapt and invest in new technologies, while others face unemployment and economic hardship. The distribution of AI's benefits is another critical issue. Advanced AI technologies, such as those in precision medicine, often require significant financial investment and are typically accessible only to well-funded institutions and affluent individuals. This disparity can exacerbate existing inequalities, as underserved populations may not have access to these cutting-edge treatments. Furthermore, AI research and development are predominantly concentrated in wealthy, technologically advanced regions, potentially leaving developing countries behind. Ensuring that AI technologies are developed and deployed in ways that promote global equity is essential. This involves addressing the digital divide and providing support for technology transfer and capacity building in less developed regions. AI also introduces new security risks that can have far-reaching implications. Autonomous drones and AI-driven cybersecurity systems are examples of how AI can be weaponized, posing threats to global security. Autonomous drones, for instance, can be used in military operations without human intervention, raising ethical questions about the use of AI in warfare and the potential for unintended consequences. Additionally, AI systems themselves can be targeted for cyber attacks. Hackers could potentially manipulate AI algorithms to cause widespread disruption, as seen in the 2018 stock market flash crash, which was partially attributed to algorithmic trading systems. AI-generated art, while innovative, raises significant ethical concerns, particularly regarding the unauthorized use of artist works for training AI models. For example, platforms like DALL-E and Artbreeder have used vast datasets of images, including copyrighted artworks without artist consent, infringing on their intellectual property rights. This practice challenges traditional notions of authorship and creativity, as AI can produce art that mimics human work, potentially devaluing human-made artwork. The art industry faces the risk of flooding the market with cheap, easily produced AI art, which can harm emerging artists' careers and financial stability. Real-world examples, such as the auction of an AI-generated portrait at Christie's for $432,500, highlight the growing impact of AI art. Platforms like DeviantArt have also faced backlash for integrating AI tools that use user-uploaded images without proper consent. Addressing these concerns requires transparency, accountability, and fair compensation for artists whose works are used in AI datasets. Ensuring ethical practices and recognizing the unique value of human creativity are essential for the art industry to thrive alongside AI advancements. As we've seen, AI's influence stretches far and wide, impacting everything from our privacy and jobs to the very fabric of creativity. The question now is, what will we do about it? As we move forward, it's crucial to demand transparency, ethical practices, and fair policies that ensure AI benefits everyone, not just a select few. Let's continue to question, challenge, and shape the future of AI together. Thanks for watching, and stay informed because the future of AI is in our hands. If you liked the video, check out this other video by us called The Downfall of a Century-Old Aviation Company.